Welcome to the Theory and Operation for Removing the Transmission Part 1, Getting to Know Your Way Around the Vehicle. In this course, you'll learn about the components that surround the removal of the transmission. My name is Lance Wiggins. I'll be your host. It's a great day to fix transmissions, so let's get started. First and foremost, we want to talk a little bit about safety. The vehicle can be a very dangerous place. If you aren't careful, spinning parts, scalding fluids, high voltages can all put you at risk. Here are some of the more common safety concerns you should pay attention to whenever you're working under the hood of a vehicle or underneath it. The list is by no means a complete. Always pay close attention to the job at hand and obey all safety procedures. One of the first steps in examining any vehicle problem is to perform a visual inspection. Look for anything obvious, anything out of the ordinary. Many problems will require an in-depth diagnosis. Others might just jump right at you. You'll be amazed at the number of times you can correct a problem simply by repositioning the floor mats or removing some debris that's sitting on the intake manifold, blocking the throttle valves or linkages. Fluid levels and conditions can cause low pressures, which will also cause slip between shifts. Check the fluid condition while checking the fluid level. Examine the fluid carefully. If the fluid's low, the problem could be a leak. Check the transmission case, sump, and cooler lines for evidence of leaks. On older transmissions that used to use a vacuum modulator, check the vacuum lines for signs of fluid. If the modulator diaphragm is leaking, it could be leaking into the vacuum system. If you can't wipe the dipstick clean, it's probably coated with some sort of varnish caused by fluid oxidation. Varnish or other heavy deposits indicate the need to change the transmission fluid and filter. Severely varnished fluid may indicate the transmission is worn out and needs to be rebuilt. Low fluid levels can cause a variety of problems. Air can be drawn into the oil pump inlet circuit and a mixture with fluid. This causes aeration. Aeration of the fluid will cause low pressure, low or erratic pressures, which will also cause slip between shifts. Air in the pressure regulator valve will cause a buzzing noise when the valve tries to regulate the pump pressure. Mechanical, electrical, and vacuum control problems can contribute to shift problems. Make sure the linkages or cables are adjusted properly. If applicable, look for any worn bushings or pivots that can affect adjustment or travel. Even a small amount of wear can have a dramatic effect on the transmission operation. On older vehicles that used modulator valves or modulator diaphragms, a problem in the modulator or its vacuum source can cause upshifts to occur at wrong speeds or not at all. Make sure you have the proper modulator on the vehicle and that the vacuum hose and line are in good condition without any kinks or cracks that could cause effect to the vacuum source. Newer vehicles use adaptive strategies. Make sure there are no codes and the system is cleared of any issues. One of the more common types of transmission problems you're likely to face is leaks. Usually, the difficulty with leaks isn't the actual repair. It's finding the leak that's the problem. That's because the leaking fluid blows back across the transmission while the vehicle's in motion, soaking everything in its path. This makes it hard to identify exactly what leak to fix. Very often, transmission technicians address this by simply recommending a complete external reseal. Don't forget that many leaks only occur under specific conditions, such as when the transmission is hot or you're driving at high speeds. This can make it more difficult to identify the leaks. A common leak is the gasket between the oil pan and the transmission housing. Retorquing the pan bolts may correct this problem. If tightening the pan bolts do not, you're going to have to remove the pan and install a new gasket. Make sure you're using the proper type of gasket for the pan and the pan's rail is flat and capable of providing a seal before reinstalling it. When installed in the transmission, the output shaft yoke should have very little side-to-side or up and down movement. Too much movement indicates a worn output shaft bushing. Replacing the bushing is easier than you might appear. There are special pullers designed to thread into the old bushing and pull it right out of the extension housing. From there, it's easy to install a new bushing using the proper bushing driver. Transmission adjustments. There are several different types of adjustments necessary for the transmissions. Depending on the specific unit you're working on, virtually all transmissions have a manual lever adjustment designed to adjust the position of the manual lever and manual valve. Don't be confused by the difference with the manual lever adjustment with the adjustment of the shifter lever indicator. These are two separate adjustments that simply adjust the position of the indicator on the dash as opposed to the actual lever and the manual valve. Always adjust the manual valve lever first, then adjust the shifter lever indicator if necessary. A worn or misadjusted manual linkage will affect the transmission operation. The transmission's manual valve must engage the selected gear completely. Partial manual valve engagement won't allow enough pressure to reach the rest of the valve body. If the linkage is misadjusted, it can cause poor gear engagement, slipping, and excessive wear. The selector linkage should be adjusted so the manual valve detent position in the transmission matches the selector, detent, and position indicated. Anytime you disassemble the linkage from the levers, it's recommended to replace the grommets, if necessary, that retain the cable or rod. Use a pry tool to force the cable and rod from the grommet, then cut the old grommet. You can use a pair of pliers to install and snap in the new grommet into the levers and the cable or rod into the grommet. Always check the linkages and cables to make sure they're connected properly and operating freely. Any binding, kinks, or looseness in the pivots or connectors indicates a problem that will affect transmission operation. Later model transmissions may not have a throttle cable or they may be drive-by-wire. They rely on electronic sensors and switches to monitor engine load and throttle position. Make sure there are no obstructions by the drive-by-wire throttle valve motor or intake area. If line pressure is too high, it can cause harsh or delayed upshifts. It can also cause part throttle and wide open throttle downshifts to occur earlier than normal. Adjustments can make a big difference in shift timing and feel. Some transmissions use a kickdown switch, typically located at the upper post of the throttle pedal. Pressing the throttle all the way closes the switch, which signals a forced downshift. To check the kickdown switch, make sure the engine is off, press the throttle slowly to the floor, and listen for the click just before the pedal reaches wide open throttle. Others use adaptive strategies to reset the shift's patterns. Make sure you always perform the reset and test drive the vehicle through its drive cycle test. Several sensors and switches provide the computer with information on vehicle operating conditions. Most of these sensors are also used to calibrate engine performance. The computer then determines the appropriate shift time for maximum efficiency and shift quality. Although electronically controlled transmissions are relatively reliable, they also introduce problems. Some common problems that affect transmission operation include incorrect battery voltage, a blown fuse, poor connections, a faulty input sensor, damaged solenoids, crossed wires to the solenoid or sensors, corrosion at an electrical terminal, or improper installation of an accessory such as stereo or GPS modules. A visual inspection of the transmission and the electrical systems should include a careful check of all electrical wires and connectors for damage, looseness, and corrosion. Loose connections, even when clean, usually only make intermittent contact. They'll also corrode and collect foreign material, which can prevent contact altogether. Service procedures. There are two basic types of transmission service available today. The traditional service, which includes removing the pan and replacing the filter, and the complete fluid exchange service. Both have their benefits. To perform a traditional service on most transmissions, you must remove the oil pan and drain the fluid. Some transmission pans include a drain plug, which makes draining the fluid sump much easier. Check the bottom of the pan for deposits and metal particles. Slight contamination or deposits from clutches and bands is completely normal. Other contamination could indicate a problem. The problem with the traditional service is that it only drains the fluid that's in the sump, which is usually 3 to 5 quarts. As much as 4 to 7 additional quarts of fluid remain in the converter, clutch drums, and servos. You can drain almost all of the fluid if the converter has a drain plug, but those drain plugs are pretty rare on units with converter clutch. A fluid exchange service flushes virtually all of the old fluid out of the transmission. This service usually involves disconnecting one of the cooler lines and using the transmission's natural flow to push the old fluid out, while the service machine pushes new fluid in to take its place. From there, you perform the fluid exchange service. This allows you to replace all of the fluid while making sure the transmission is in good shape and replacing the filter. There are a few manufacturers that offer their own unique fluid types. BMW, Mercedes, or some common manufacturers. Always check the manufacturer recommendations before adding or replacing transmission fluid. You cannot interchange fluids. You will destroy a transmission on the test drive or during operation. All fluids are made specifically for those vehicles. However, there are a number of additives on the market designed to modify Dextron and Mercon to simulate an HFM or other types of fluid. Many manufacturers approve of their use. There's no replacement for the quality-based film. Many transmission problems such as chatters, slide bump shifts, harsh shifts, etc. can be traced back to using economy-grade transmission fluid. Some additives can help reduce those effects, but the better solution is to use a good quality transmission fluid from the start. Some transmissions have adjustable bands. If the band is a shifting band, improper adjustment can cause shift timing problems, such as slipping and or slide bump shifts. On holding bands, improper adjustment can cause apply problems, such as harsh applies. In general, band adjustment is a maintenance item. It should be done as part of a normal maintenance or during the rebuild. Once a problem develops, it's usually too late to adjust the bands. All automatic transmissions require some type of cooler to remove the heat from the transmission. The cooler can either be used by the engine coolant to remove the heat from the transmission, or could be air-cooled. The specific location of the cooler will vary from vehicle to vehicle. Many are mounted inside one tank in the radiator. One line feeds the heated oil to the cooler, the other allows the cooled oil to flow back to the transmission. If coolant leaks into the transmission will have to be rebuilt. If the cooler failed, replace the cooler and flush the cooler lines before installing the transmission. External cooler leaks result in traces of ATF around the source of the leak. If the cooler flow is below specs, you can try flushing it with a cooler flusher. Always recheck the cooler after flushing to see whether the coolant flow is back to normal. Never use the flusher to check the cooler flow. The flushing solvent is less viscous than ATF, and even a plugged cooler will allow more solvent through than ATF. If flushing doesn't bring the cooler back to specs, replace the cooler. The vehicle's speedometer is usually purely electronic, which requires no mechanical connection to the transmission, or it can be driven by an output shaft through a cable. Most oil leaks at the speedometer cable can be corrected by replacing the O-ring seal. On some transmissions, the speedometer drive gear is a set of teeth machined into the output shaft. Inspect this gear. If the teeth are slightly rough, they can be cleaned and smoothed with a file. If the gear is severely damaged, replace the output shaft. Other transmissions have a drive gear that's splined to the output shaft, held in place by a clip, or driven and retained by a ball that fits into a depression on the shaft. Regardless of the method used to attach the gear, check the retainer and make sure the gear is being held firmly in place and in proper position. The engine and transmission mounts on a front-wheel drive vehicle are important to the operation of the transaxle. Any engine movement may affect the length of the shift and throttle cables and can alter gear engagement. Delayed or missed shifts may be a result of linkage changed as the engine pivots on its mounts. Problems with the transmission mounts may also affect the operation of rear-wheel drive vehicles. But this type of problem will be less noticeable than some types of problems in your front-wheel drive vehicles. Many shifting and vibrations problems can be caused by worn, loose, or broken engine and transmission mounts. Visually inspect the mounts for looseness and cracks. To get a better look at the condition of the mounts, push up and down on the transaxle case while watching the mount. If the mount's rubber separates from the metal plate, or if the case moves up and down, replace the mount. Install the engine support fixture and attach it to the engine hoist or crane. Lift the engine just enough to take the pressure off the mounts. Remove the bolts attached to the transaxle mount and frame and mounting bracket, and then remove the mount. To install the new mount, position the transaxle mount into its correct location on the frame. Check the alignment of the mount and lower engine back into the mount, then tighten the bolts to their specified torque. Remove the engine hoist fixture, and from there, your mount has been replaced. This will conclude our course on removing the transmission, Part 1, getting to know your way around the vehicle. We want to thank you for participating in our virtual training solutions powered by ATRA. Until next time, let's keep fixing transmissions together.